Okay. Again, it looks like we're changing gears totally from what we did yesterday. Okay, yesterday we talked about antiderivatives. Before that, we were finding the areas of rectangles. Today, we're talking about something called rectilinear motion. This is tied in with antiderivatives. Really, it is a way of, it's an application of antiderivatives. So we're going to work with it some. Probably you won't see a lot of calculus that you're using in this, okay? But we're going to walk through and use the calculus to begin with, and then hopefully you can say, oh, I've done this enough, poof, here I know what the formulas are. So let's look at these problems, and then you'll have lots of time to work on other activities that you might have going on. Use the fact that A of t is equal to negative 32 feet per second as the acceleration due to gravity. Neglect air resistance. What does that mean?
A of t is negative 32.
Which is what?
Gravity.
Okay? Neglect air resistance. We aren't worried about there's no puff of wind going to come along and poof, blow us back up in the air, okay? It's just, you're just going to fall. So we're starting with that. Now, and we're asked a question. A ball is thrown vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. How high will the ball go? All right? So, who can tell me what we're trying to get out of this? We're trying to find the highest point. So what do we need?
Maximum.
We need a maximum. A maximum of what? We don't have a formula. But if we what would we need to, what are we trying to maximize? The what? The height. Height or position, okay? Height or position. So we need to figure out a position formula somehow or another here. Okay? Well, we know that acceleration is negative 32. What can we do with that?
Velocity.
We can integrate acceleration. And if we integrate acceleration, what will we get? Velocity. Okay? Now, notice that I put a d of t out here, not a d of x. Why did I do that? Yes. Our initial function was a of t, so that's what we're looking at is acceleration due to time. It's negative 32. If we're integrating negative 32 dt, Miranda, what are we going to get? Negative 32t plus a c. What does that c mean?
Can add a constant.
It's a constant. Do we need to know what that c is in this case or not?
Yes.
Why?
Because we're asking something exact.
All right, so how are we going to figure out what that c is?
Find the particular.
And how do we do that?
Initial velocity, we're given the velocity of 60 feet per second.
So what does that mean?
Plug in 60 where you have dt.
Plug in 60 for what?
Oh, when VT, right? V on the left side.
Okay, so when t equals what?
0.
0, I already wrote down. V equals 60. Does everybody understand how we know that?
Why did we say T equals 0?
Because the initial velocity of 60 feet per second. We have to give it some number. When did we start counting? Okay?
Oh, so it's like you threw the ball up in the air and then you're like 1.
That's right, exactly. When did we start counting? You know, if you think about this, a ball is thrown, I'm throwing it from right here. If I say Sam, time me, when's he going to start the timer? When I let go of it, at 0. So initially is at 60, so boom. There's t is 0, v is 60. If we plug that in over here, we get 60 equals c, don't we? Therefore, c equals 60. So now we have a particular solution for v. It's negative 32t plus 60. Okay? Well, does that do anything for us here? No. Well, what do we need to do now then? Now, we said we didn't want them.
We need to find, we need to find position. We do the integration of.
Yes, we need to find a position. We're trying to maximize a position.
So we have to integrate the velocity.
So we're going to integrate the velocity. So to find position, which is normally delineated by the letter S, we're going to integrate velocity with respect to time. And if we integrate velocity with respect to time, we're integrating negative 32t plus 60. Wes, tell me how we're going to, when we integrate that, what are we going to get?
The 60 will turn into 0. Well, it will go. Oh, no, it'll turn into 60t.
60t, very good.
32.
All right. All right. Remember, we've got a 1 here, so it's going to be t squared over 2 and still got a negative 32 out there, which that will clean up to be negative 16 t squared plus 60t. Okay, so we get what out of this answer here? We get 16 t squared equals 550. So t squared is 550 over 16. So we can figure out an answer from that, right? 5.86.
What am I doing? I just got 48.
Is that our answer?
No, you gotta plug that t back into the
Why would that not be
b
negative
sub
32?
0.
Negative 16 and positive 32? Oh. Now, and this is what students are going to make the mistake on if you're going to make a mistake here. That's not the answer. Because what did it say? With what initial velocity? We were trying to figure out what v sub 0 is. Can we figure out what v sub 0 is? Well, we've got v sub 0 equals 32 times t, don't we? So we can say the initial velocity is 32 times 5.86. 187.52 feet per second. Now, I am bad about leaving the units off. I encourage you to be better about it than I am, mainly because when you get to FRQs, you're going to see questions that say, find this with units, or be sure to include units. If you don't put the units, you don't get a point. But guess what? If you do put the units, even with nothing else, you get a point. So be sure you know what your units ought to be and write those down. But be sure and put the units, 187.52 feet per second. That's how fast I've got to throw it up if I want to get it to the top of the Washington Monument. Is that complicated? That's pretty straightforward there, isn't it? Okay? By the way, guaranteed to be one or two of these problems on the AP exam. Guaranteed. All right, the final problem we're going to look at today, and this is the one I told you about earlier and said that y'all don't remember here. A balloon is rising vertically with a velocity of 16 feet per second, releases a sandbag at the instant it is 64 feet above the ground. What's going to happen to the sandbag the moment it's released? No.
It's going to sit still for like...
No.
It's going to go up.
It's going to go up.
No, this is what you told me earlier.
Yeah, and you don't believe me, okay? Because think about it. It's going up. As soon as it's released, it's still moving up. It's not going to move up long. But those cartoons that you saw where somebody, y'all remember the Roadrunner and the Coyote where he runs off the cliff and doesn't fall until he realizes he's off the cliff? You can really run off the cliff and stay there. Not very long, about a fraction of a second, but you could really do that for a second and then fall off the cliff because you've got momentum taking you out there, okay? So we are going to let go. It's going to go up just a fraction of a second before it falls. How many seconds after it's released will it strike the ground? At what velocity will it hit the ground? Solve the problem. Go. I'm going to bring your formulas back over here. Talk to your neighbor, talk to your friend, talk to your enemy.
I really didn't even stay up late on break. I would just go to sleep at 11 and wake up at like 10. So much sleep this week. So v sub 0, that's your initial velocity, right?
Uh-huh.
If we had no initial velocity given to us, should we use what it just says is velocity?
Well, that's the question. what do you, when are you going to start the timer here?
Oh, when the sandbags are released.
So what's the velocity when the sandbag's released? 16. Because it's still going up, right?
Oh, yes, yes.
So it does have an initial velocity. What else does it have?
Initial position.
Which is?
And the gravity is -32, therefore we need to find the time.
Okay. How many seconds after it's released will the bag strike the ground? Okay.
Well, we can.
Well, let's plug in and get our real formulas here. S of t is -16t squared plus 16t plus 64. V is -32t plus 16. And A is -32. It's not really worth writing that down. So, whoopee, we got our formulas. Proud force. Now, what do we do for A? Which formula do we use?
It's for T, so.
We got two formulas that's got T's in it.
Maybe I'm making it too. I'm looking at it and the time is 1/2.
Okay. How did you get that?
-16 to move it over there.
So you use the velocity one. Okay. And that's a common mistake here. Answer me something, everyone, because this is why I like this problem. If what he said is right, then he's answered B part 2. How fast is this thing going when it hits the ground? Or better question, is it going 0 when it hits the ground? No. It's going 0 right after it hits the ground. What do you think?
Would the velocity, like, would V of t be, like, would we set the V of t equation equal to 0 to solve for t? Because when it hits the ground, the velocity is not going to be anything, and that's what we're looking for is that time.
All right, and you missed my point here. The velocity is going to be something when it hits the ground. The velocity is not going to be something 1/10 of a second after it hits the ground. But there is going to be velocity when it hits. There's actually going to be a little velocity after it hits the ground because it's going to spread out and splat a little bit on the ground. So,
Could you
go.
do the first one and
Yeah.
just make it
The position 0. Where it's at is going to be 0. When it hits the ground, that's our 0 point. Now, how do we know the ground's 0?
Because it's 64 feet above that.
Right. We said the initial position was 64, which was 64 feet above the ground. So we can say, we can take this top one and set it equal to 0. -16t squared plus 16t plus 64 equals 0. How are we going to solve that?
Out of 16.
Take out a 16. Thank you, sir. All right, so if we take out a -16, ooh, did all that wrong. T squared minus t minus 4? Is that what y'all got?
I left the negative.
Okay.
Yes.
So what are you going to do now?
16 doesn't equal 0.
Yep.
Then you can do factor.
I don't think it'll factor. So I don't think it'll factor. So how do you solve a quadratic? If you don't remember, use the quadratic formula. 1 plus or minus the square root of 1 minus 4 times 1 times -4 all over 2 times 1. You need to know that thing, okay? 1 plus or minus the square root of 17 over 2. We get 2 answers. It's going to hit the ground twice. One of these will be negative. So really the only answer we're concerned about is 1 plus root 17 over 2. Which, how many seconds after the release, I would figure out what that is. That's 4 point something, 5 point something, 2.5 something is my guess. .56 seconds. So 2.56 seconds after we release it, it's going to hit the ground. Now, Sam did an interesting thing a while ago, and he set the velocity equal to 0 and got a half a second. What does that mean? That's when the velocity was 0. So what does that mean? When we let it go, what did we say happened? No, it goes up.
So half a second after we let it go.
Right. For the first half second, it's going to rise. Then it's going to reach its maximum, and then it's going to fall for 2.06 seconds and splat hit the ground. Now the question is, at what velocity will it hit the ground? So what do we do to find B part? Yep, find V of 2.56 for B part. V of 2.56 is negative 32 times 2.56 plus 16. Yep. So that's negative 64. Ooh, I don't know what that is. Y'all are smart people, or you have calculating devices.
I got negative 65.9.
Feet per second. Does the negative make sense there?
Yeah, it's going down.
Because it's going down, okay? So that's the speed at which it will hit the ground. Okay? You have this homework you can play with. Did everybody get my email last night about the web assigned due next Tuesday?
30 problems?
30 problems, yeah.
Is that like 30 possible point entry things, or like 1 through 30?
1 through 30, okay? So, but I've given you a nice long time to do this over, okay? And you've got FRQs Friday. So